Okay, this is the short answer section. We're going to start with question 1. Student wants to investigate the electrolysis of a mixture of 3 metal nitrate. So you have aluminium nitrate, silver nitrate, and copper 2 nitrate. The total volume of solutions is 100 ml. So I'm going to assume that you mix all 3 solutions together into one electrolyte. Inert carbon electrodes are used and the voltage is carefully increased until electrolysis begins. Draw a schematic diagram for this electrolytic cell. Clearly indicates the cathode, the anode, and their polarities, flow of electrons, and the ions present in the electrolyte. All right, simple question. Not so simple when you can't draw properly on the writing part. I'm going to try my best. I hope you do a better job than me. You can show the power supply like this, or you can just simply write out power supplies. I think it's up to you. It shouldn't be a big deal. But if you want, you can label negative and positive so you remember. I do not like that, so I'm going to draw that again. So we have the electrodes in an electrolyte. It always looks like a face to me. You need to label cathode and anode. So this is your cathode, which is carbon, solid. And here's your anode. Oh, sometimes it does this. It's just, I don't know why though. I think it has something to do with the cursor being up there. Okay, so this is your anode, which is also carbon, solid. The total volume is 100 ml, so I'm going to make a note of that. I think it will become handy in the future. Flow of electrons. Electrons flow out of the power supply into the cathode and away from the anode. And the ions present in the electrolyte, you will have aluminium 3 plus, NO3 minus, silver plus, and copper 2 plus. Now it doesn't ask for the concentration, so I'm not going to draw it. I'm not going to label it in the cell. Okay, write an equation for the half reactions that occurs at the cathode when electrolysis first starts, given that a metal is produced. This is a classic electrolysis question. You need to predict the products of the electrodes using the electrochemical series. So we already listed everything. Now we obviously also have H2O because these are solutions. So I'm just going to go back to the electrochemical series and I highlight everything that's present. You don't need to consider nitrate ions because I think for most cases we're going to assume that it is inert. So I have aluminium, I have silver, copper, aluminium, and water. So aluminium's here, copper is here, and let's buy water. Okay, so the first thing that's going to be plated at the cathode is going to be silver. Silver ion is going to be plated, reduced into silver. Plus electrons going to Ag solid. That's going to be the equation for the first reaction that occur. So reduction of the strongest oxidizing agent present. If the current is 500 mega amps, how long in seconds would it take to complete the plating of this metal? I'm not entirely sure how you can have melting of a metal. All right, first hurdle, which was in bold, let's not forget, is to convert milliamps to amps. Okay, we need to work out the time in seconds, so that's our unknown. Now, if you want to work out time and you're already given the current, it has something to do with charge because we know that time is charge divided by current. But in order to work out the charge, I need to know the number of mole of electrons. I have a mole ratio up here, which is good, but you need to know the number of mole of electrons. And the key word here is that you want to complete the plating of the metal. You actually provided with the concentration of the metals. You have 0.010 molar of silver nitrate. So the concentration of AgNO3 is 0.010 mole per liter with a volume of 100 ml, which I am going to convert into 0.1 liter. Okay, this is good because I now have I can work out the concentration. No, I can work out the number of mole of silver ions present, which is the same as the number of mole of silver that needs to be plated, and from there the number of mole of electrons, and from there the charge, and from there the time in seconds. Okay, so number of mole of silver, which is the same as the number of mole of silver ion, which is the same as the number of mole of silver nitrate because of a 1-to-1 mole ratio, which is C times V, which equals to 0.001. 0.001 mole. Okay. The number of mole of electrons in this particular case is the same as the number of mole of silver, which is also 0.001 mole. And then I can find the charge, which is n of electrons times Faraday's constant. So we have 0.96,500, which is 96.5 coulombs, and then you can find the time in seconds. So T is Q over I, which is divided by 0.5, don't forget to convert. So I get 193, yep, 3 sig fig, 193 seconds. So 1 mark for answer. Let's just change the color because I want to show the marking scheme as well. Okay. So 1 mark for answer. Obviously this is a mark. Now for this one you get the first mark for getting the number of mole of electrons and the second mark for calculating the charge. Okay. If the electrodes are cleaned at this stage and the voltage slowly increases until electrolysis occurs, describe what would happen at the cathode. So when you clean the electrodes and all of the silver ions has now been plated to silver, it's going to move on to the second, that's not this one, the second strongest oxidizing agent, which in this case is copper 2+. So what is going to happen now is you're going to have copper 2+ ions being plated at the cathode. That's the answer for this question. So we're going to have Cu2+ ion are plated, reduced. Now, if you don't want to mention the fact that copper may potentially stick onto the electrode, that's okay. As long as you mention that copper 2+ ions are reduced into copper solid, which is what happened at the cathode. Could all of the metals be plated in this way? Explain your answer. Okay, all the metals. We also have aluminium, but aluminium is not going to be plated unless all the water is removed. You do have a very low concentration of aluminium ions anyway, so there's no way it's going to be able to outcompete water in any shape or form in this case. So you want to be very clear with your explanations here. The answer is no. Why? What is that? The answer is no, and the reason is because aluminium ion, and you have to make sure you say that it is the ion, is a weaker oxidizing agent. Be very correct with the language. Agent than H2O, and will not be reduced. Alternatively, you can say water is stronger than aluminium ions. Will not be reduced at the cathode. That's a weird word. Reduce at the cathode. I think that's the end of this question. I hope it is anyway. Alright, yep, that's it. Question 1 done.